Good morning, dear students. We continue the classification problem. Here we have some definitions and some concepts. So it is regarding comparison of classification rules. Comparison of classification rules as we did in decision theory also. The first definition is let D is equal to W1, W2, Wk be a non-randomized classification rule. If Fix is the PDF of X given the population Pi, that is under the population Pi or under the hypothesis Hi, then the probability of misclassifying an individual of Pi to Pj by the rule D denoted by Pj given I by D. This is Pj given I by the rule D. That means probability of misclassifying an individual of the population I to the population J. This is the notation is given by Pj given ID is equal to integral in the region Wj Fix dx. Ij goes from 1 to k, I not equal to j. This is the probability of misclassification and the probabilities of correct classifications. That is, probability of correct classification should be, this is Pii. This is incorrect. So you modify this. This should be Pii, not Pji. So I can use the eraser. I don't know here if I remove. This should be removed. This should be I. This should be I. Pii. You correct it. This is Pii. Okay. No problem. Then Piid is equal to integral in the region Wi Fix. So this is probabilities of misclassification and probabilities of correct classification. Now expected loss of misclassification. This is the risks or the expected loss. What we have already seen in first semester in decision theory. For I goes from 1 to k, 1 is equal to summation over all j pji by the rule D. That is probability of misclassifying an individual of the population Pi to the population Pj. So if you sum all the probabilities, then this should be equal to unity, because you have to classify the individual A into one of the k populations for sure. Okay, so this j is from 1 to k. So it is very sure that the population, the individual A will be classified to one and only one of the k populations, P1, P2, Pk. So this is simplified as Pii, and for those j's which is not equal to I. So there are k minus 1. This is sum over the k minus 1 remaining populations, and this is Piid. So now the quantity Li is equal to summation j Cji Pji, Cji into Pji. So sum over all j's. Cji is the cost of misclassification, Pji is the probability of misclassification, is called the expected loss or risks of misclassifying an individual of population Pi. And the vector L prime, this is the vector L prime, L1, L2, Lk is called the loss vector or the risk vector associated with the rule D, So for every rule D, this is of course the non-randomized rule, because we have the partition W1, W2, Wk. There will be associated the vector L, and this L is nothing but the vector of risks or vector of expected losses. Now, similarly for a randomized rule D, where we have, in the case of a randomized classification rule, we have the probability distribution P1, P2, Pk. The expected loss is defined like this: Li is equal to integral P1x into C1I. This is the cause of misclassification, and the Pkx Cky, okay, Fix dx. So this is the expected loss or risk of misclassifying an individual of the population Pi, and the vector L prime L1 L2 Lk is the associated loss vector. So this is the same thing. This is for randomized classification. The earlier one is for non-randomized classification rule. Now here is the ordering. Given two classification rules D1 and D2, D1 D2 may be both randomized or both non-randomized. So we cannot cross among D1 and D2 with associated loss vectors L1 prime and L2 prime. So L1 prime is L1 L2 Lk, L11 L12 L13 L1k, and for L2 prime is this L21 L22 L23 L2k. We say that D1 and D2 are equivalent if Li1 is equal to Li2 for all I. Okay, this is very clear. If the corresponding components of L1 and L2 are all equal, then D1 and D2 are said to be equivalent. Next, D1 is at least as good as D2 if Li1 is less than or equal to Li2 for all I. This is less than or equal to. You note this. Number 3, D1 is better than D2 if Li1 is less than or equal to Li2 for all I, but there is a condition with strict inequality for at least one I. So this inequality should be strict for at least one I. In that case, we said that D1 is better than D2. That means loss is smaller. So D1's loss is smaller than D2's loss. Therefore, D1 is said to be better than D2. Number 4, D1 and D2 are incomparable if for some I, this is small I, Li1 is less than or equal to Li2, and for some j, Lj2 is less than or equal to Lj1. See, the reverse inequality comes for some j, and for some I, this is the earlier one, Li1 less than or equal to Li2. The reverse thing happens for some j. So in that case, we said that D1 and D2 are incomparable. Okay, last definition. A classification rule, may be randomized or non-randomized, is said to be admissible if there does not exist any other rule better than delta. If there does not exist any other rule better than it. Okay, so this is the same definition or concept that we did in the decision theory in statistical inference. Clearly, if there are two admissible rules, then they are incomparable. So we will continue in the next video some more definitions, and this you have to get the idea of these concepts and definitions for today. So for today I will stop here. Have a good day ahead. Stay safe, stay home.